Just one more quick example of taking some old code that we have and rewriting it using a method. This is our Monte Carlo simulation that we wrote to find the area under the curve y equals x squared, which is a parabola, from the point 0 to the point 1. And suppose I wanted to modify this to work with any function, not just y equals x squared. I would have to come in here and I have to find, well, where does it compute the function? Here's my f of x value. Let me close this up a little bit so you can see more of the window. Okay. Here's where I define the value of my function, and here's where I compute it. F of x equals x times x. X times x is x squared. Remember, we're finding the area under a parabola. Suppose we wanted to find the area under a different curve, x to the fourth, or sine of x, or cosine of x, or whatever. I would have to come in here into my code, and I would have to change that function in the code. Which, fine. But suppose I wanted to use this code in a situation where I might use it to find the area under a bunch of different functions. And I don't know when I'm writing the code which function I want. Instead of just putting the x squared in here to represent my function, let's create a method. I don't want to just call it function. Let's call it my function of x. And I will write that method so that it takes the value of x and computes some function, f of x, that could be x squared, or it could be x cubed, or it could be sine of x, it could be anything. So I'm going to create a new method called my function. Let me collapse my main method here for a second. What do I need in order to create this function? I need to tell Java that it's a public method, that it's a static method. I need to tell it what it returns. It's going to return a decimal value, so it's going to return double. I'm going to call it my function, and I'm going to give it the value of x. Okay, the value of x is some, in this case in the Monte Carlo, it's some random x and y point that I chose. So I'm going to compute, I'll just call it result equals, and I'll just do x squared, which is what it was in the first place. So nothing should change about my program. And then I'm going to return that result back to main. So this program should run exactly the same as it ran before. Remember, the area of underneath a parabola from 0 to 1 should be 1/3. So if I run this with a big enough n that I get a good simulation, we'll do 1,000,000 points. 1, 2, 3, 4, 5, 6. The computed area under the curve is 0.33381. That's pretty close to 1/3, which was the right answer. So it works. But now if I want to use a different function, I don't have to touch my main program at all. My main program just calls my function. And if I want to use a different function, I just go to the my function method, and I change the function. Suppose I want to do x to the fourth. I just make it x to the fourth. That's a lazy way to do x to the fourth, but I don't feel like looking up the syntax for the power function. What's the integral of x to the fourth from 0 to 1? It's 1/5 x to the fifth, which is just 1/5. So this should be 0.2. Let's run it. Run with a bunch of points. 2, 1, 2, 3, 4, 5, 6. And again, if you haven't taken calculus yet, just trust that if you had taken calculus, you would know that the integral of x to the fourth, the area under x to the fourth from 0 to 1 is just 1/5. Simulate it with 2,000,000 points, I get 0.1999265, which is really close to 1/5. Right? 1/5 is 0.2. Do it for x to the, we won't do it for sine of x. We can do any function now that Java knows about. The way to get sine is, what's it, math.sine of x. Now math.sine of x isn't an integral I can do in my head, but first of all, I don't know if the sine function in Java takes degrees or radians as its argument. You would have to look that up, and you hopefully already have looked that up in your the assignment I gave you to create your own little math library to refer to in the future. But now changing the function that I'm integrating is just simply a matter of changing the calculation inside of this method, and I can leave my main program unchanged. And that is when using methods is really, really useful. And there might be something that in different programs you want to use differently. Here, I don't have to change anything in main at all. All I have to do is change the myFunction method, and it changes what gets computed inside of this Monte Carlo. I could go one step further. I could create a method called Monte Carlo that I give the lower and upper bounds instead of just 0 and 1 being declared. Where to declare that here? I guess nowhere. I guess I just oh, area under is 1, and here I start where oh, when I call math.random, that gives me a number between 0 and 1, right? I could change that to be from some minimum to some maximum. And I could have a Monte Carlo method that I give the minimum and the maximum, and it does the simulation, throws n points. I could give it the minimum and the maximum and n, and it would do this, and all I had to change every time I ran this is the numbers that I give to the method. So the more modular I make my program, the more flexible it is. And the more flexible your methods are, the more reusable they are. And that's where we want to move towards, is a place where I've got reusable methods that I can use in a whole bunch of different contexts. So I've already got things that we've done in the past couple of examples are things that would make, if we went back to Project Euler and just searched all of the Project Euler problems that involve prime numbers, now we have got pre-written methods of our own that we can just drop into code and use anytime we need to calculate prime numbers. So this is another example of just taking a piece of your code and putting it into a method and making that code as modular and reusable as possible.